Welcome back to our final session on how to build Blackjack. Of course, even after this session, there is still some scope for further work. There are, for instance, definitely ways to implement betting, which I haven't done. And of course, you are more than welcome to try to add these features to your game. So first, what we need to do now is we have to add the bank. So if we go back to what we currently can do, let's just run this one more time. So we can add number of players up to 4. So if I just put in 2 players, I put again in Sue and Amy. And then I can ask for more cards. In the case of Sue, she would definitely like 1 more card, and 1 more, and 1 more, and I think maybe now stop. And Amy might try 1, and she just got Blackjack, which is great, and of course you stop it. So what we now do is we have to add the bank, because in the end we always play against the bank, and then we have to decide actually who wins the game. Of course, the bank does not take cards in the usual way. You have to somehow code the bank's behavior. So in this particular case, I will just hard code the bank's behavior based on a very, very simple decision. Of course, this can be optimized in many ways. You can introduce a learning algorithm, for instance, using neural networks. You could consider that the bank is able to count the cards, so you can determine probabilities of winning. And then you have to decide actually how the bank makes a decision, maybe assuming risk-neutral behavior. So there are different ways to do this, but this goes beyond the scope of this first project, as our focus is really on beginners, and I only want to really focus on some rather basic concepts. But of course, all of that can be extended and could be done in further work. Okay, so what I do now first is I add the bank to my players. That I have to do in my game. So here is my game setting. There are different ways of actually doing this. So if you look at add player, that simply adds players based on the name of the player or based on the player object. So you could, it's one option, you could add the bank player in here without actually naming it explicitly. Yeah, so that could be done. So you could create a player object and you name it bank, and you can throw it into this command on the game class. Of course, you could also work in display. I think working in display might be slightly easier, but again, that's really a matter of a matter of taste. Now, what I do here is I, of course, enter the players. So that is the part that would enter them. And actually, after I enter all the players, the human players, I could now add the bank in here. So I just make a note here, and we have to try this add bank to list of players, and I would put the bank at the end of it. Anyway, the append method is exactly doing this. So I can always find the bank in the list of players just by referring to -1 using indexing, which simply means I go to the last player. So how do I add the bank? Well, it's quite easy. I just use the same command here. I append the list players further, and here explicitly I state as name bank. Yeah, and I just do all capitals to make it distinct. Now that would do it. Of course, now this is returned and put into the play game instance method, which then means it would also go into the game add player method. So that's the method up here. So that should be fine. And then we play the first round, which again is fine because I also have to give cards to players, so that is fine. So when I go into the first round, it's perfectly fine that in the first round also the bank would get the 2 cards. So that is acceptable. In the display, then I have to start thinking more carefully, and I also made a note here just for bank. I have to think more carefully about who wants more cards, yeah, because the bank does not actually ask for cards in the terminal, so I have to adjust my display. So how do I do this? Because now, of course, my game players, they have one more player in here, that's the bank. So what I do is I have to remove the bank out of player want cards, because that determines my asking for cards. And also in here, in the for loop, I have to adjust this as well, because game.players also contains the bank, but I don't want to have the bank in here. So what I need to do is I have to adjust and have to cut out at the last player. So how can I do this? I could write slicing something like this, and the last one I slice, which is the -1, should be exclusive. Let's try whether this works. The first one, the 0, actually I don't really need, but let me just try this before we go any further. It's quite easy to make mistakes here. Let me just try. Okay, so again I put in 2 players. Again it's Amy here and maybe Tim, and they get all the stuff. Okay, that's fine. You see now the bank also gets cards, which is fine. Amy has already 20, you don't need more, so I just say no. Tim has 13, I take one more and I go to 20 and then I stop, and that is it. Yeah, so it seems to work. I don't ask for the bank here, which is fine. So that is working. I'll just clear the screen here. Good. So what we now have to do is we have to add further below what happens to the bank. And as I mentioned before, I don't do any fancy algorithm here. I just simply make a very simple rule, which isn't that that amazingly good, but I think it's enough. It's sufficient to make this game quite usable. Okay, so what I do now is I just basically say, so as long as you have not enough score, and I would put this at 18, I simply take more cards, because it's unlikely for the bank to win in this case. Which is a very simple thing to do, without referring to what other players have, without starting counting cards and using the bank's leverage. So I don't go into this, but of course it could be extended, but it would be quite substantial additional fun to do this. So what I do is I simply say while game.players, and then I index to the bank, so -1, the last position is the bank, dot score. So basically this gives me the bank's score is less than 18. So if you have less than 18 as a bank, I simply take one more card. Yeah. So what I do here is I just say game, and you have it actually here. So that's basically what it is. So I use my instance method next card on my game instance, and the player here is simply the last player, which is written here. So that would do it. So it's, you see here, object-oriented programming at work. It makes things actually very, very concise. Good, so that should do it. So the bank will now take more cards, and let me just test that. But it's better, maybe we do it in a second. The best thing now to do is to show who wins. Let me do this, and you will see in a minute that this actually works. So who wins against the bank? Yeah. So if we do that, we could have a go at it. So what I do now is I just go through all the players excluding the bank, because I always play against the bank. So basically what I do is I use the same for loop I have up here. So this is what I do, and I start with different branching here. So the first thing to do is to check first whether the player is bust. So once you're bust, of course you anyway lost. Yeah, so there is no hope for you whatsoever. So what I do here is I simply check for every player except the bank, yeah, based on the slicing I do. If player.score is larger than 21, so basically you're bust, and I just make the following statement in this case. So I just say print, and I do a formatted string here. I use the placeholder, and I just say player.name is bust with score, just to check whether this actually is correct, which is simply player.score. And then I could maybe that's anyway enough. So once you're bust, that's fine. So oops, that I didn't intend. I should have done this. Okay. Alright, now I make a mutually exclusive statement. So if this is the case, then anyway you're bust and you're out. Yeah. So if that is not the case, I check another condition. So I check this condition first, I check the other condition next, and that's basically when my bank is bust. Yeah. So again I go into game.players and I move into -1 position, so I talk about the bank. So if the bank is bust, where the bank is bust, and then of course the player would win in this particular case. So I just copy this here into this position. I should put in print. So player blah 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 wins in this case. So if you're not bust, you win if the bank is bust. Okay, and then I just put this on the next line, and I state again using my bank player. I don't have to do this, I can just write out bank directly, but I'm just optimizing my object-oriented programming here. So the bank is bust with score, and I just put in the score here, which is that dot score. So that should do it. Good. So what next? Well, the next case to check is if the player has a larger score than the bank. Okay. Now we have the player score here. Just copy this. So if player.score is larger than the score of the bank, so we just do this, and again I put a colon here. So in this case, simply the player wins, and I just can copy paste that basically. So I can say, okay, player dot name wins with score blah de blah, and then we have bank. Maybe I just say has score because it's not bust, has score, and so on. That should do it. Okay. Now finally, if that is not the case, if you don't beat the bank, well, you lose anyways. I just do an else statement here, and what I do again is I just copy paste that. Let me see, and put in some further information. So we say wins has lost with score, and bank has. Well, I think that's fine. Yeah, so the bank wins. Okay. Good. So let me just try this. So that might actually do it, but of course it's so easy to make some mistakes. You always have to check and try. Let me to Python main.py. Good. How many players do we want? Let's put in 2 players. We use Amy, we use Sue, and here we are. So now we have Amy has an 8 of hearts, a jack of diamonds, so you get 18 score. Sue has a jack of clubs and a 9 of hearts, so it's 19. And the bank has a 2 of spades and a 5 of spades, and the score is 7. Now there's one more thing which one should maybe address in some future work. The bank only discloses the first card, not the second one, so the bank has some information advantage. Yeah, so we haven't implemented this, but it can be easily done. It's just, of course, some further branching you have to do, but that can be done quite easily. So now we ask here, Amy, do you want one more card? Well, you have 18. It's a bit tight, honestly speaking, so I just go for no. Sue, one more card. Well, 19, I would also go for no. Okay, and now we see Amy has lost with score 18. The bank has 21, so it's Blackjack. Sue has lost with 19, the bank has 21. So you see the bank keeps taking cards based on our rule, and in the end actually wins. Okay. Now that's quite nice, and of course we are out here. Yeah, of course, then we could implement, something like a loop where we have, where we ask now repeatedly, do you want to play one more game? That can be again easily implemented. That's perfectly fine. Another thing which we haven't done is the option to split as well. So under certain conditions, I'm not a blackjack expert, you can split your cards, and again that can be of course implemented. Betting is quite easy to do, and then of course you can work on the decision rule for the bank. Yeah, let's play it one more time. So that's working quite well. Let's maybe move up to maybe just throw in some rubbish, and yeah, that works as well. So we check for this, put in 3 players. Now we go all out here. Sue, Tim and Amy, they all play. Sue has 10, so yes, you want one more. You go to 16, one more. You're out anyway. You go bust, it moves to the next person. So Tim has 8, so you would take one more. They take one more. Oh, okay, that's pretty cool. So would win. Amy has initially 12, so you would take one more. So you see now as ace moves to 1, which is what you want. It's a soft hand because otherwise you would be bust. You take one more and you're bust. Yeah, good. And you get as outcome below, you get Sue is bust with score 24, Tim wins with score 21, bank has score 19, and Amy is bust with score 23. That's pretty cool. Yeah, so we have actually now the outcomes announced, and of course once you know who wins, it's very easy in the code to adjust for the betting. Yeah, of course then you have to have an additional attribute on the player class where you store cash basically, and you have to also then adjust for different types of bets. But you know, in the end, it's a working game. It's not bad, and we just used Python. We didn't use any fancy libraries here. We did not build a GUI, so it's a very old school terminal-based application. Okay. The last thing I want to show is, well, I want to now package it. Yeah. So how can I do it? How can I freeze the application? We already know this. I can use the pyinstaller. Yeah. So once I'm happy with it, what I can do is I can use the pyinstaller, assuming it's installed on your system. If not, of course, you have to use a pip install and do this. It's a console base. I put in here the flag C because I actually run this in the terminal, and then I put a flag F. I put it all into one file, and I just put in main.py, and that hopefully runs and would package my application. That might take a while. Okay, so that's fine. So it's all done. So when I now go into my folder, that's not a live folder here, So that's the folder here. I have this spec file, which I don't need, and then you have the dist and the build file. Yeah, so if you go into the dist file, you see the main. So that's your file that you can actually execute or copy paste this into the main. I can remove these files and folders, get rid of that, and that should run. Now, because it's console based, the best way to execute this is actually through the command line. So again, I put in cmd here, and I simply now execute main.exe. Yeah, which means I don't actually run Python explicitly. I execute the executable file. That might take a while, but here we are. The game seems to work. I put in now 2 players, Sue, Amy, that's fine, and here we are. The bank is also on board. Sue already has 20, so I don't take more. Amy has 13, I take more. And of course now I stop, and now Sue has lost with 21, Amy has lost with score 21, bank has scored 21. I'm not so sure, because I'm not a blackjack expert, whether this actually is correct. Yeah? So if you have blackjack and the bank also has blackjack, who wins? I really don't know. I have to check that. For me, I'm all into the coding side of things. I'm not the expert on blackjack. I never played it in real life. For me, this is not strategic enough. I'm all into poker. Okay, so that's all I want to cover. For me, the main thing is not actually having a fantastic blackjack application. The main thing is to show you how to use the different elements of object-oriented programming we covered, and how to turn this into something that resembles a usable application. Yes, I hope you enjoyed that, and I see you next time.